Alright, welcome back. Now, on the board, we're going to be talking about empirical formula. Alright, empirical formula is like the beginning for molecular formula. Now, empirical formula gives us the quantity or the number of elements in the compound, but it does not really give us what is in the compound. Alright, so we have, let me give an assumption. We have C2H2. Now, this could be a molecular formula, but it could be an empirical formula. But for this term now, let's assume this is an empirical formula. Now, this empirical formula is not telling us what element it is. Although, if you can use the homologous series, you can have this as a name. But let's assume it is not known. This is an empirical formula, and this is an empirical formula for benzene. Alright, so from here we have a very short number of carbon atom and hydrogen atom here. Alright, no, the normal compound for benzene is C6H6, but empirical formula does not tell us this. It only gives us the number of elements in that compound. Alright, from here, this question will be getting to understand how empirical formula works. Alright. So here, they said, what is the empirical formula of a compound which contains 60% oxygen and 40% sulfur by mass? Alright, now, like in our O-level way, so I'll be explaining it that way because it's more simpler compared to that in your textbook. Alright, so we have oxygen here, oxygen having 60%. Alright, we have sulfur 40%. Now, we're going to be dividing these numbers or these values by their masses. Now, they gave us oxygen as 16.0. Alright, so we're going to be dividing it by 16.0. We're going to be dividing sulfur by 32.0. Now, we are having an approximate value as 3.75. Then here we are having 1.25. Now here we are going to be dividing. After we're done with these parts, the next part is to divide by the lowest or the smallest value. Now, what is the smallest value? Between 3.75 and 1.25. 1.25 is smallest, so we're going to be dividing by 1.25. Now, 3.75 divided by 1.25. We're having here as 3, then obviously we'll be having here as 1 because this will divide this. Here's 1, here's 3. Now, we're having here oxygen, here as sulfur. So, obviously, sulfur. And here, this 3 will go for oxygen. And this 1 will go for sulfur. Now, to rearrange this compound, the normal state we have in here as SO3. Now, this is the empirical formula for this compound from the question above. Alright. Now, we're having a question here which is a 1.05 gram sample of a compound containing only 3 elements, which is carbon, hydrogen, and oxygen, was burned completely to give 1.738 gram of CO2 and 0.721 gram of H2O. What is the empirical formula of the compound? Alright, now they said this 1.50 sample is a compound, but they don't really know how they are added, the atoms, if it is one atom of oxygen or 3. Now they gave us the mass of the compound. Now they gave us the mass of the compound that was, let me see, how do I put it, that was evolved, that was made after the reaction. Alright, so we have 1.738 gram of CO2. Now this is CO2. We have its mass. So yeah, we're like finding the mole of this compound. Now we have 1.738 over the formula weight of this is 44. Mean 0.0395. Now carbon here is 1, so if we multiply it by 1 to get its own mole, multiply it by 1, it gives you the same value. Alright, now let's look at that of oxygen. Water, sorry. We have H2O equal to 0.721 over the formula weight of water is 18. So we are having 0.04 approximately. Now hydrogen here. Now we're looking for the mole of hydrogen and a mole of carbon. Why I'm not applying for the oxygen, because this compound here contains oxygen. This compound here contains oxygen. So we can't know the mass by calculating it for each one and adding them, because they have different atoms in different elements. So we have to find the mass of hydrogen and carbon, then we minus it from the mass of the sample, so we can get the mass of oxygen. Alright, so here when we're multiplying, since hydrogen here is 2, we're multiplying it by 2 as well as we did here, so we're having 0.08. Alright, now this is the mass of the compound. Alright, so we have to add the two of them. This is for carbon and this is for hydrogen. Now we have to find the mass of each of them, then minus it from there. Now how do you find the mass of the, yeah, we already have the mole, number of mole. Now to get the number of moles of carbon, sorry, the mass of carbon will be equal to the mass over the molar mass. Carbon is equal to the moles. The moles is what we have there. Alright, so the mass is unknown, so we have to cross multiply. Okay, we have to cross multiply here. We have the mass is equal to, what is the mole? 0.0395 times the molar mass. What is the molar mass of carbon? 12. Now same goes for hydrogen. We have hydrogen is equal to mass over the molar mass is equal to the mole. Then we have it as mass is equal to the mole 0.08 times the molar mass of hydrogen, which is 1. Do not change. Alright, so we have here as 0.08. Then here we have we have here as 0.474 gram. Now we already have the mass of carbon, mass of hydrogen. Now we have to add the two of them, then minus it from the total mass of the sample. Alright, so we have the total. The total will be carbon plus hydrogen plus oxygen is equal to 1.5 gram. Now we already have the mass of this, which is carbon, as 0.474 plus hydrogen 0.08 plus oxygen, let me call it X, it will be equal to 1.5 gram. Now if you cross multiply, if you call it like 10, we have X as 1.5 minus open brackets 0.4 plus 0.08. Alright, we're having here as the mass of oxygen as 0.946 gram. Now, since the mass of each element in the sample is known, so we can find the empirical formula of the compound as stated. Alright. Now, what was the mole of carbon? So we have the molars for carbon 0.0295, and that of hydrogen as 0.08, and that of oxygen we have add it as mass there, so we have to convert that mass to mole, like the gram to mole, which we all know as mole is equal to gram over molar mass. So we have mole is equal to 0.946 over oxygen 16, which will give us 0.059 approximately. Alright, so we have 0.059. Now, as we said, we're going to be using the least number to divide. Alright, so we have 0.0395, 0.08 and 0.59. Now the least number here should be carbon, so we're dividing each element by the least mass. So we have 0.0395, 0.0395, 0.0395. Alright, here should be 1. Here is 2 approximately, then here is 1.5. Now, in the empirical formula, they don't approximate directly. Now, we have to find a value that if it multiplies everything here, the point dies away. Now, the value that will multiply, the least value that will multiply everything here, that will make this decimal go away, should be 2. So 2 times 1 will give you 2. 2 times 2 here will give you 4. 2 times 1.5 will give you 3. So we're having the compound as C2H4O3. Now this is the empirical formula for this compound. Thank you.